Hello and welcome. My name is Suyash Nagar and I'm here to present my capstone project for course Machine Learning Foundations for Product Managers from Duke University. To begin with, we will quickly review the criteria for evaluation. First, we will begin with the modeling approach. Here, we will see whether I was able to correctly identify the modeling task, feature to use, and possible algorithm. From there on, we will move to model building. Here, I will try to provide for a couple of algorithms and their combination, maybe use hyperparameter and see if we are able to validate the model. Then we will deep dive into model evaluation to see the possible matrices I can use and whether I was able to demonstrate those. And finally, we'll look into the model interpretation, whether I was able to correctly interpret and clearly communicate the performance of the models I have created. We have been following the CRISP DM process, which is cross industry standard process for data mining, and we have all these steps that we'll be looking into. To begin with the topic, what I have been assigned with is combined cycle power plant. And the business understanding here is to predict the electrical usage for combined cycle power plant, which uses a different combination of gas, steam, and heat recovery generators and turbines to generate power. My understanding of the data is it has five columns: temperature, ambient pressure, relative humidity, exhaust vacuum, and the energy output, which we will need to predict. Here, depending upon the scenario, because we need to predict the energy output, so the regression model make more sense here, and I have given the general usage of regression model. And from here, we can clearly see that we have a relationship between dependent variable, independent variable. We will be able to see all those features and the labels to predict the outcome. And also the regression analysis or the model is primarily used for two purposes, which is prediction and forecasting. Pretty much what we are trying to accomplish here. Then moving on to the matrices that I have identified. So we have decided, or I have decided to go with the mean squared error, root mean squared error, and R2 to evaluate all the different model and combination. With this, I will move on to the first model, which I have created using simple or the very basic linear regression.
For my project development work, I have decided to go with VS Code as it is pretty easy and clean to use. Initially, what I have done is imported all the required module for doing different operations, such as splitting test data, importing linear regression, then also importing the matrices what we are going to use. So I will run it to show you the output. So pretty much done. Now the next step that we need to do is load our data, all the observation that we have in a CSV file to a pandas data frame. And as you can see, it has loaded the data and showing the top five records. After this, we'll move to the data exploration phase. So initially, what I want to do here is to see how does my data look, whether it is clean, does it have some empty or the null values. So I will quickly run the hit function. It will give me top 10 records since that's what I have specified. Now I'm going to check whether I have any nulls in my data frame. So for all the record, as we can see, it returns false. So that signifies that we don't have any blanks or null in the data, and the data is already kind of clean. But just to confirm, because we have almost 9,500 plus records, I'm going to see the sum of the nulls. So just in case if in any column, if we have summation more than 0, that will signify there is still a chance that there are few nulls. And I can do it with the same function using the excess. So it is returning none. That means our data is good. So since we have explored the data now, we will move with some of the statistic functions. So I will describe how does my data set look. And now here we can see we have 9,568 record. That's a common across all the uh, columns or the observations that we have. The mean is looking good. We have standard deviation. Then we have different matrices over here, and we can see the max value as well. Once we have seen the statistic, now we can go ahead with deciding on what are going to be our feature and label. So good thing over here is most of the things are numerical, so we don't have to worry about the categorical data here. We are not going to deal with that. So as we already know, the final goal is to predict PE, the energy output, what we have. So remaining things are going to be a feature. So to start with, I have decided to take all other columns as a feature like ambient pressure, temperature, the vacuum, and relative humidity. So as you can see here, I have decided my what are going to be my feature and label. So I'm going to quickly execute it. Pretty much the same what we have seen above. Now, uh, since we are done with the kind of initial way at looking at the data, so but since it's a huge set of record, it will help us if we can visualize the data. So here I am just simply creating the figure to show the data what we have. So it will not make a lot of sense right now. Now we will try to plot histogram. I'm gonna quickly execute a couple of next few steps here. We are trying to uh, draw a mean and median, the box plot, just the basic feature like giving the title. And as you can already see here, it doesn't have any data yet, but you can see the mean and median, which is pretty close. So now for each of the numeric feature in our observations, I am plotting it for all the columns. Here we can see the correlation of ambient pressure and the power outage. So we can clearly see the correlation over here. Pretty much the same way we can see the correlation for other features we have decided in terms of features and label. Now we are just trying to separate the feature from label for further processing. So we are done with the basic visualization. Now we will move towards fitting the model. So here we can see the top 10 features and labels. In order to train the data, first we need to split the data. So I have decided to go with 70 to 30 ratio. As we can clearly see here, we have 6,697 rows for training, and then remaining goes to test set, that is 2871. Now, like I said, like we want to start with the simple linear regression. So that's what I'm going to fit. So now the model has already been fit. We will evaluate the model with the test data that we have segregated in the first step. And we can clearly see here the top 10 predicted label and the actual label. But since we have such a huge number of records, it's not good to see everything in terms of an array. So we'll go ahead and try to plot it. So here we can see the relation between predicted label and the actual label along with the mean line. So now here, like initially called out, I have decided to go with the mean squared error, RMSE and R2 as my main evaluation metric. So I'm going to run it, and it has given me like we have MSE of 20.36, RMSE of 4.51, R2 of 0.93, which is kind of a good baseline numbers. So now we know what probably we need to work on. But starting with a linear regression, it's always good.
Right. So just now we saw the simple linear regression, and I have updated the metric numbers what we have obtained just to provide a little bit of additional information. So we have not used any hyperparameter and scaling yet. With this, we'll move on to the different regression algorithm. Moving on to the next, so this time we will use lasso. So I have just executed the code, and we can see our metrics. So now we have MSE of 20.45, RMSE of 4.52, and R2 of 0.93. So not a significant gain or a loss yet. Moving on to the next one. So now we'll try decision tree algorithm. So I have just executed the code, and here we can see MSE of 24.33, RMSE of 4.93, and R2 of 0.91. So now let's see the performance of decision tree regressor compared to simple linear regression and lasso. So looking at it, it looks like it has degraded. So we'll continue searching for the best algorithm, and we'll move on to the next one. Now we'll move on to ensemble algorithms. So I have a random forest regressor and a gradient boosting regressor. So we can see the performance of both with our metric. Let's see how it looks comparing to the algorithm we have executed so far. So we can see the slight, not slight, a lot of improvement in random forest regressor using ensemble. And there's an improvement in gradient boosting regressor as well compared to the first basic three algorithms we have tried. So now we will move on to trying hyperparameter and scaling. Now we will move on to something a bit more complex. So this is an example of using hyperparameter. The trick with the hyperparameter is to find the right learning rate or the estimator. So you can see here, this is the combination I have tried with, and these are the results what I have achieved. So now you can clearly see how much improvement we have got with the hyperparameters. Now I will move on to scaling. So I have tried two different kind of scaling. First one is with the gradient boosting regressor, and these are the results what I have achieved, like 14.56 of MSE, 3.81 RMSE, and 0.95 of R2. Not bad though. And the last one I have tried is random forest regressor with scaling. So here you can see the MSE of 11.032, RMSE of 3.32, and R2 of 0.96, which is still like is kind of a improvement. Now we have executed all the algorithms that I was planning to demonstrate. We can see we have this huge list of different algorithms with hyperparameter scaling, and some of them without them. So we can clearly see the performance of each metric. So with this, we can clearly see the random forest regressor, the ensemble, gradient boosting regressor, and random forest regressor with the scaling has been performing well with the use of parameter and of course with the scaling. So with this, we can take a call which algorithm we want to consume and move forward with it and deploy it in production. This brings us to the end of the demo. I hope I was able to explain all the required things and provide meaningful information. So thank you for listening and viewing to this demo.